Hi, I'm John Spriggs, and I'm giving a talk today called Automating OS Hardening with a little help from my friends, CIS Benchmarks and Ansible. So, as is fairly customary in talks like this, I should introduce myself. I'm John Spriggs, sometimes called John the Nice Guy. I'm an automation and orchestration specialist, focusing mostly on cloud security. I'm also a distinguished engineer of the company who employs me. Well, actually, that was last week. As of this week, or next Monday rather, I'll be a technical account manager for a very, very large company. Don't know what that all entails yet, but anyway. I also podcast, blog, do Twitch and YouTube streams and, well, stuff like what we're about to go through. Just a little bit less polished. And I like to talk. My wife said I should just leave it there, but, well, I should follow that up by saying I like to talk at conferences. So this is exactly the sort of stuff that I like to talk about. And what am I going to be talking about? Well, this is a talk for the blue teamers out there. I'm talking about hardening your operating systems and server applications with a framework called the CIS Benchmark. I'm also talking about automation tool called Ansible. Now, this may already be in use in many of your organizations, or if not Ansible, then something similar. The main alternatives that I know about are Puppet, Chef, and Salt. But I really know Ansible, so that's what I'm going to be talking about. So let's get on with this show. Here is a mildly tweaked version of the CIS Benchmark website. This lists all of the benchmarks they offer, covering operating systems like Amazon Linux, Debian, Ubuntu, Red Hat Enterprise Linux, and Windows. They also cover browsers, virtualization platforms, Office applications, and even server services like Apache HTTPD, the Bind DNS service, FreeRadius, IIS, SharePoint, MySQL. I did remove the list of mobile operating systems whilst I was shuffling the list around, and by mistake, I forgot to add it back in, but it is supposed to be there too. Now, this page is the one that you get to from whichever benchmark you click on from the main site. So if you go and search for anything in the CIS benchmark site, you get to this page eventually. They email you a URL, which takes you to another list, which gives you the actual downloads. They don't really care which benchmark you're actually clicking on, just that your email address is valid. Because it's an email address, I'm not really sure whether you get put on a spam list at that point, because the company that I used to work for had actually signed up for a corporate membership of this site, so I get to go in a different way. But I don't recall getting any extra spam when I signed up for it with my personal address. So your mileage may vary. I don't know. Sorry, just got lost there for a second. It's also worth mentioning the terms and conditions here as well. You're not allowed to use this as a commercial offering. So you can use it to harden your own servers, but you best not offer a CIS hardening service if you want to go with the free account. I think even the paid corporate service prevents that too. So just check what you're planning to do with those benchmarks before you use them. Okay, that's all the legal disclaimers out of the way. Let's take a look at the Ubuntu benchmark. Well, actually, it's just the table of contents for right now. You see, each of those numbered points there, 1.1, 1.1.1.1.1, and so on and so forth, these are checks to perform. Now, on my screen, I can see file system configuration, which covers preventing certain kernel modules being loaded, setting volume mount configuration values. Next is software updates, file system integrity checking, and so on. Just on this one page of the table of contents, there's over 40 checks. So let's look at the next page. Oh, look, more checks. Setting up access control, banners, disabling GUI logins, removing server services, network protocols. You see, this is blanket guidance. Turn off what you're not using on the box. Justify what you are. It's just like a check test. Strange that. Anyway, next page, more content, more networking stuff. Enable a firewall, configure it, turn on Audit D, use it. Then you get more Audit D, more logging, authentication, sudo, SSH, PAM, users, permissions, etc. Goodness, this is just the table of contents. Well, here we are, last page. All in all, over 250 checks in here, spanning 11 pages just of content and nearly 500 pages of actual content. So should we have a look at one of the actual checks? So this is a simple check. I've skipped past the check whether a kernel is loaded module, well, a kernel module is loaded checks, and gone straight for the install a package for file system integrity checking. Basically, you've got 6 sections here. What sort of profile machine is this check relevant to? Which CIS controls does it support? Why would you want to run this check? How do you run this check? And then how to remediate a failure of that check. This one also lists a few other bits and pieces, like the details about the problems you might run into when you're using this. So this is looking for a particular software package, in this case, AID, and it's telling you how to install it and then how to perform basic configuration on it. Even without automation side of things, these are actually really useful documents. So what's next? Well, let's look at Ansible. Now, I thought you might have had a bit too much text on the previous few pages, so I drew a pretty diagram. Well, say pretty. Ansible is an open source project from Red Hat. You can run the command line tool on any Unix-like shell, including Linux and OS X. It doesn't natively run on Windows, but if you're running Windows Subsystem for Linux, WSL, it'll run quite nicely, albeit slowly, on there. If your environment doesn't use WSL or let you run a Linux Bastion host, you can install the Ansible Automation Platform, which is a charged product from Red Hat, or their open source upstream project, AWX. AWX is basically an unbranded version of the Ansible Automation Platform, and in theory, runs on any system that runs Docker. Personally, I've only tried AWX on Ubuntu and Ansible Automation Platform on RHEL. AWX and the Ansible Automation Platform have engines that run the same playbooks that the command line tool Ansible runs. So from this point, I'll refer to everything as though it were just the command line version, which is good. Otherwise, you'd have even more pointless screenshots in the forthcoming pages. So Ansible uses an inventory file or an inventory script to determine which hosts it needs to talk to. It also reads a YAML file, which details what plays it's going to execute, and a play is a combination of a host selection and a collection of tasks which will be performed sequentially across all those hosts. Each task is executed against one of the following: a server connected over SSH or WinRM, a network device over HTTPS or SSH, and a cloud or SaaS API over HTTPS. So what might that look like? So here's a simple representation of that previous slide. So on our Unix-like shell, we execute the command Ansible playbook, telling it which playbook to read and which inventory file to read. Then here's our playbook. The playbook has a single, in this case, play, which is named confirm comms. And that lists which host it will target and the tasks it wants to be performed. Now, in this case, the first task is going to be a connection check using the module ping. That's not the ICMP or UDP ping, but more like the IRC ping pong challenge response. It's named confirm we can connect and registers the response in the comms check variable. Next, we output our response using the debug module, which we pass an argument of the variable comms check that we previously defined. We also say we only want this command to run if the previous command didn't fail. So that's our playbook done. In our inventory file, we first list the local host. Now, if we run Ansible without any inventory, you get the local host added automatically. But as soon as you add an inventory file, you need to manually specify the local host. Now, here we can see that the local host variable has a variable assigned against it from the outset. The Ansible connection equals local. So by default, Ansible talks SSH. Anytime we're not using SSH, we need to tell Ansible that. We'll see another example of that in a bit. So next we jump down to the group Linux, all Linux servers. Now, again, we've included the local host in this group, as it's actually running WSL, so therefore it's kind of a Linux environment. I've also added a web load balancer, and because that doesn't resolve to a specific host in either the DNS server nor in our SSH config file, I've specified the real host name it will connect to. So this means you can give a long, complex host name a short alias, or it can give a meaningless host name or IP address, descriptive names for your logging purposes. And lastly, in this block, I've added a DNS resolvable range of 3 backend servers. Now, naturally, those won't actually resolve. Well, you'll see that in a bit. I've also added some Windows servers, even though they're not referenced in the playbook because, well, maybe there's another playbook which targets Windows servers. Or perhaps we didn't get to those tasks yet when we were writing the playbook. Either way, we have 2 IP addressed hosts, AD1 and AD2. And like with the load balancer, they don't have DNS names. Instead, they have an IP address. We also have 7 DNS resolvable RDS servers. Excellent. We're not going to connect to those, but you'll see what happens. Anyway, these Windows servers all have some common connection variables, like they use WinRM, for example. they have a common service account to log into them. And if I were being completely and entirely insecure, I'd dump a plain text password for this service account into the inventory. But I'm not completely foolish. No, instead, I've stored that password in an encrypted file in the group vars directory for this group of servers. Now, Ansible has its own name for this encryption system called Vault. It uses standard encryption primitives. Offhand, I don't know what they were, but I think it's AES-256, something like that. So it's not completely unreasonable. And actually, this is one of the few serious benefits of Ansible Tower and AWX, which is that AWX, or Ansible Tower, can segregate the action of storing access credentials away from users who are actually executing the Ansible playbooks. So they're still in one central location, and you can harden and protect that host accordingly, but they're not completely accessible to everyone. Anyway, let's move on. So the last thing we have in this inventory is a final group called All Servers, which has two child groups associated to it, All Linux and All Windows Servers. So in theory, we could target both platforms with a standard set of configuration steps. We don't do that here, but you can see how you might extend this out to do other things as well. So what does this actually look like when it runs? Oop, skipped too far. So let's run this video. And it's stored off elsewhere, so sorry about that. It's not going to look very pretty for a second. Let's run this. So, Ansible playbook, -i, inventory, playbook. You see it confirming the comms, running the play, confirming comms. And it does, the first thing it does is it runs this gathering facts task. Now, you see there it's failed to connect to some hosts because it couldn't resolve the host names. After that, it ran the test. It then output the debug results we asked it to. And then you get this recap at the end, where you see here the fact that the localhost ran okay. Yeah, it was able to run 3 tasks. The 3 back-end servers were unreachable because it couldn't resolve the DNS names. And then the load balancer it connected to fine. So that's good. So let's close that screen and come back to our slides. So how else can we use Ansible? So that previous slide, and in fact all the rest of these slides as well, actually don't do really any templating. But this is quite a large part of why I like Ansible. You see, almost anywhere you see a defined variable in an Ansible playbook or a config file, it can be templated. And by that I mean Ansible will on demand render that templated string to build a new value. Like in the YAML file here at the top. We provide a default value when something's missing, so some var might be defined somewhere else, and if it's not there, we use a default value. You can run if, else if, else, end if script, and you can even do ternary, if value is true, then return true. So if value is X, then return Y, and if it's not X, then return Z. You can also create template files as well. So like in the bottom block there, you can see a for loop there, stepping over items to build up a more complicated more complicated configuration file or documentation file. And you can also see that there's you can use these strings in tasks. So let's put Ansible and the CIS benchmark together. So here we have our setup, importing a role which currently has 2 files in it. The defaults file, which stores some overridable values, and the task, which will be executed as part of that role. Now, I'm not going to go too far into what this role does right now, but basically it does the remediation steps we documented in the benchmark. But only if that overridable value, down here, execute CIS harden OS 1111 is true. Now, when we put that role into your playbook, it becomes a reusable block of code anywhere that you want to use it. This screen shows 2 roles as part of that test playbook, embedded into the environment using a Git submodule packed. Now you can see where you might put those files to test things. But you can also store this role elsewhere in your environment and ask your developers to add it to their requirements. There's loads of documentation about this on the Ansible website. Now, if your team is already using Ansible, then perhaps they'll contribute fixes, tweaks, improvements to your playbook. You never know. Now, if you're interested in how a role gets put together, this slide shows you what files go where. Feel free to screen grab this or take a picture. Or even as this is going up as a video, you may want to play it all back and, catch a specific part of it. Even better, if you want to get involved in the project that I'm writing, to write these 240 checks for Ubuntu and later some of the other CIS benchmark checks, then click on the QR code that's there. If not, come back to look at the URL that's in the top of all of these slides. Click through to that link at the bottom there to the GitHub repo. On the other side there, you'll see that I've already written some of those tests. In fact, I've written the first 8 of them. So that's good. Anyway, thank you very much for listening to my presentation. I wish you lots of luck getting yourself started on using Ansible or the CIS benchmarks, or even better, maybe use both. And if you want to talk to me about any of this lot, then please feel free to give me a shout. Thanks very much.